In part 9 of our series, we ask, do carbs mean more fat? To explore this, we must consider metabolic oxidation priority. Metabolic priority dictates a strict hierarchy for fuel utilization, the conversion of energy for cellular and body function. Our fuel or energy comes mainly from food, carbs, fats, and proteins. Contrary to the popular understanding that carbohydrates are inherently lipogenic, it is suggested that the body is biologically wired to prioritize the oxidation of glucose from food over almost any other fuel source, unless this natural wiring is disrupted. Lipogenic refers to the process or ability of promoting the conversion of substances, especially carbohydrates, into fat within the body. When lean real food carbohydrates, such as steamed sugars or intact grains, are consumed, the system identifies this as high-priority energy. In de Novo Lipogenesis, observations indicate that this pathway is remarkably naturally inefficient in us for a reason, which suggests that under standard physiological conditions, healthy adults, the body prefers to oxidize these carbohydrates for immediate ATP production, energy, store them as glycogen in the liver and skeletal muscle, or dissipate the energy as heat through diet-induced thermogenesis. Simply, our bodies are much more likely to burn carbohydrates for energy than store them as fat, based on DNL. The distinction between a lean carb and a refined carbohydrate lies in the fiber matrix. This structural component is essential for regulating the rate of glucose entry into the bloodstream. Fiber acts like a sort of buffer, functioning as a biological governor to ensure a paced insulin response. Observations in hormone mechanisms suggest that when glucose is introduced alongside its natural fiber, the body maintains metabolic flexibility, the ability to efficiently switch between burning fuel and stored fat. Without this buffer, a glucose surge can temporarily inhibit fat oxidation. However, with the matrix intact, lean carbs support a sustained metabolic burn. Based on this, it is a common physiological misconception to attribute weight gain to carbohydrates when the mechanism often involves the passive fat trap. When a lean carb is consumed in isolation, it is oxidized. However, when paired with unbalanced fats, such as processed oils or high-fat animal products, the body faces a fuel surplus. Because the physiology is occupied with the high-priority oxidation of glucose, the secondary fuel, the dietary fat, becomes redundant for immediate energy needs. Since dietary fat is already chemically structured for storage, it is efficiently shunted into adipose tissue, while the carbohydrates fuel the current metabolic demand. In this scenario, the carbohydrate acts as the primary fuel, while the accompanying fat becomes the stored cargo. Therefore, lean real food carbohydrates, when consumed without these unbalanced lipid additions, remain a highly efficient resource for maintaining a lean physiological state. For both holistic health and high-performance athletic health, the physiological conclusion remains consistent. Real food carbohydrates are complex packages containing phytonutrients, minerals, and structured water. When maintained as lean carbs, whole and free from processed oils, they function as the body's most efficient fuel source. This approach aligns with the body's evolutionary requirement for high-quality, glucose-based energy without the metabolic consequences of excess lipid storage, which translates to improved, cleaner mental energy fueled by a better diet, based on individual suitability and health status. Integrative health, holistics, is transitioning into go deeper health, high-performance health. Subscribe to support this resource and go deeper.